This week I'm going to answer some questions that came in from the community. If you have any questions, you could email's in the description. You can fill out the form that's in the description. You can join the Discord, submit questions there, or just leave a comment on any of the videos and I'll try to answer as many questions as possible each week. A couple questions that we're going to take a look at this week is the Blitzer College Algebra versus Stewart Pre-Calculus, how to manage personal life with college life, graphing this function of f of x equals x minus 2 over x minus 1, and simplifying I to the 46th. So the first question, this was on a comment on a video about another textbook, and this person just wanted to know what was a better book between Blitzer College Algebra and the Stewart Pre-Calculus. And that really depends on what you're looking to do with like your math background, if you're self-studying and just learning everything as possible, or if you're preparing for a calculus class. It just really depends, because college algebra and pre-calc, those are actually two different classes. A lot of people don't know that, but those are two different classes. You can learn college algebra and still be fine in calculus, and you could do pre-calculus and be fine in calculus. So it doesn't really matter. I took college algebra before I took calculus. I've never actually taken a pre-calculus class. It just took college algebra. Like some colleges just have a college algebra, trigonometry, calculus route. So you don't necessarily need to take pre-calculus. But I would say if you're looking to go into calculus and you want to be as prepared as possible, I would probably just go with the pre-calculus book rather than the college algebra book. They're very, very similar, but there are some slight differences that might prepare you a little bit more for calculus. And to be honest, between Blitzer and Stewart, I love Blitzer. I think he's a great author. I love the style that he has. I think it's very welcoming for students who don't like math. I think it's very engaging for people who aren't really into math, and even students who do enjoy math, it's really good. But I think Blitzer does a really good job of pulling people in and relating it to them a little bit better. I like his examples that he uses a lot. He uses a lot of just relevance to everyone's life kind of examples, where Stewart is a little bit more rigid and a little bit more mathematical with it, and that's fine. But Stewart is an amazing author, and I think if you can get your hands on a Stewart pre-calc book, I would go that route. But if you only have access to college algebra, you'll be completely fine either way, and I love Blitzer. So I think he's a great author. I use his college algebra book. I actually have a review. I think I've talked about this book a couple times. I don't actually have the Stewart pre-calculus book. I've never even seen it. Most colleges will use Blitzer college algebra, but the Stewart, they might use Sullivan for pre-calc sometimes, but I've never actually seen the Stewart pre-calc book. But to answer the question between those two, if you're looking to go into calculus and you can get a pre-calc book, go with pre-calc. But if you can only get the college algebra book, you'll be fine either way. How to manage personal life with college life. So this is a great question. This came in through an email that was sent to me. There's just a student was trying to manage the change going from high school to college and having their own job, family life, like that kind of stuff. So to answer this question, share my relevance here with this type of scenario. I work in a community college, and in a community college, the student population is very different than a university setting, because at a community college, you're getting 18-year-olds through 40 to 50 to 60, even 70-plus-year-old people who have full lives. Like they have kids, they have responsibilities, they have full-time jobs, they have family members that they're taking care of, they have all these other engagements going on, where college, yes, they're attending full-time, but they have all this other stuff to do full-time. Where at a university, you'll see students who all they have to do is just show up to class, and they live in these dorms, and they just have to manage to wake up on time, which they can't even do sometimes, and get to class. That's it. They don't even have jobs most of the time. And if they do have a job, it's like through the school, where the hours are like 10 to 20 hours a week, and they're worked around your school schedule. So it's a little bit easier to manage getting a job at a university, like as a student, rather than being a student at a community college and working at Dairy Queen or working at McDonald's. It's very hard to manage that, because places like that, like Target, they're not going to really care what your school schedule is. They're going to say, I need you at these hours, and then you're trying to work around that. I can't tell you the number of students that I've had who have said that I can't take this class because I have work. or I can't come into class because I have work. Like, just work always gets in the way. So how to manage that is, if you can find a job where they work with you, and I would try to find a job on campus, whatever college you're at, whether it is a university or whether it is a community college. Community colleges have tons of student jobs available. I worked throughout my whole entire college career. I worked in the college that I was attending. I worked as a tutor. I worked in like a public relations office where I just had to like send out newsletters and stuff to the school. Like, it was really, really easy. They worked around your schedule. So I would try to get a job inside the school. And then outside of that, like, there's nothing I could say about managing your personal life, like your family life. Like, that's really, really difficult. And like I said, I teach at a community college, and I see a lot of that. I see a lot of students who are taking care of family members, whether it be they just have their own kids, like multiple kids, or they have parents that they have to take care of and manage. So then that becomes difficult to navigate. And the best thing you could do is just create a schedule for yourself. Just know when your job starts, know when your classes starts. If you're in a sport, activities, clubs, whatever it is, just make a schedule and come up with times for each day that you know from 1 to 3 you have open. So that should be your homework time. My biggest issue I see with students and trying to navigate college work with personal life work with work and all this other things is just not being consistent of like, oh, I have a gap from 1 to 3. I'm going to just not do anything with that time and essentially waste it. And then you're trying to find extra time somewhere in your day to make up for that lost time that you didn't capitalize on when you had that gap of time in the afternoon. So that'd be my best suggestion to you, is just make a schedule, come up with a plan of how are you going to manage all of these different aspects of your life. So the first question that I want to look at, or the first actual math question, is simplifying I to the 46th. So this came up in a video, and there was a lot of discussion about it, so I wanted to go over this simplification. So I to the 46th, so just a couple of reminders here on i's. I is just I. So that was I to the first. So I to the first, let me rewrite that. So I to the first is just I to the second is -1. So when we have like the square root of -1, what that becomes is I root 1. Square root of 1 is 1, so you just get I. So then I squared is -1. I to the third is -I, because if I to the third is I squared times I, and using your multiplication of the same base rules, that'd be I to the 2 plus 1, which is I to the third. So that's I squared times I. I squared is -1 times I, so that'd be -I. So I to the third is -I, and then I to the fourth is 1. And the reason being I to the fourth is 1 is because if you have I squared times I squared is -1. I squared is -1. -1 times -1 is +1. So these are like the main 4 that you should know. The I to the fourth equal 1 is really, really useful. It could really help you out. For example, on I to the 46th, what I would do here is I would try to write this as I to some exponent. So I'm just going to write x for now. And then I'm going to write that to the other way around. I want to write this as I to the fourth to some exponent, because, and then this is going to be like times I, whatever is going to be left over there. I'll just use like y just to symbolize what I'm looking for here. I'm looking for an x, I'm looking for a y, just in terms of like what these exponents should be to make up this 46, because I want this to equal I to the 46th in the end. So I to the fourth, and the reason I'm doing I to the fourth is because I to the fourth is 1. So when I establish this is just 1, this is going to be 1 to some exponent. Whatever that exponent is, 1 to any exponent is going to be 1. So this whole entire term right here is going to create just 1. But I do need to figure out now what this x value is going to be in order for this to work. So if I did like I to the fourth to the 10th, that would be I to the 40, which we can go a little bit bigger. But what about if I do I to the 4 times 11? That would be 44. So that'd be I to the 44, which would put me close to 46. If I went 12, that'd be 48. That would put me over. So I'm going to do 11. So I'm going to change this to 11. So if that's 11, So this is I to the 44 right here, I to the 44. Then this has to be I to the second. And the reason being, I to the 4th to the 11th is I to the 44. 4 times 11, power to a power is multiplication, times I to the second is I, multiplication of the same base. You add the exponents, that's 46. So then we get I to the 46. Okay. So now that we did that, let's simplify this expression. I to the 4th is 1, as we've discussed, to the 11th times I squared. 1 to the 11th is 1, 1 to any power is 1, times I squared. I squared is negative 1. 1 times I squared. I squared is negative 1, so 1 times negative 1 is negative 1. So the discussion was in the comments. I did a problem similar to this in a previous video, simplifying I, and a comment came up of like, why can't we do I to the 4th to the 11.5, I think it was, right? Because 44 times 11.5 is 46. Yeah. Someone just said, well, why can't we do that? Like, why doesn't this work where I say I to the 4th is 1, and then 1 to the 11.5 is 1? The reason this doesn't work is because, first of all, you're using a decimal. You'd have to rewrite this as I to the 4th to the 11.5. And then you really get into some messy work here because it's dealing with a fraction, so then you'll end up with like the square root, because this would be yeah, it'd be like power to a power, because you're doing it gets really messy from there. So I wouldn't do with the decimals. Like, you can't really work with that because you're not translating the 11.5 correctly, because it has to become a fraction, and then it gets a little bit messy with trying to work through it that way. Because what you could do is like 11 times 1, or you can rewrite this as a mixed number. So like 2 times 11 plus 1. I'm kind of running out of room here. So that'd be like I to the 4th to the 20. 2 times 11 is 22. 23 over 2. And then you would have I to the 4th to the 23rd over 2. So 46 over 2, and then yeah, it's not going to work out. So that was the comment of like, why can't we use these decimals? It's not going to translate. I think you end up with, in the end, like square root of I after, because of that 1/2 there. You end up with like square root of I, so it doesn't work in that way. So the answer would be -1. You got to use these nice clean numbers in order to rewrite it. Last problem, I want to graph this. Now, the person that submitted this question didn't specify whether or not they had like calculus methods that they wanted to see, or just using pre-calc. So I'm going to just use pre-calc methods only because the calc methods will take like 15 minutes, 10 to 15 minutes if I really want to explain it a lot. I mean, I could go through it pretty quick using calculus methods, but I'm going to just do pre-calc where you don't have the knowledge of calculus. So I'm just going to look at this as like, how would I go about graphing this? So the first thing you want to be aware of when you go to graph this is the domain. The domain is all the x values, like where does this exist when we are looking at the x-axis there. So first of all, when we try to identify the domain, we have to be aware of the asymptotes. So I'm going to take so let's check the vertical asymptote. So I'm going to take the denominator, set it equal to 0. So x minus 1 equal to 0. I'm going to add 1, x equals 1. So at x equal to 1, we have an asymptote. X equal to 1, we have a vertical asymptote. So the domain then is going to be from -infinity to 1, not including 1 though, so I'm going to put a parentheses there, unioned with 1 to positive infinity. So this is going to do something. It's going to approach this asymptote in some way, and then we have that asymptote, so it doesn't exist at that asymptote, and then it's going to pick up on the other side. So we have that gap in the x values at x equal to 1, so that's our vertical asymptote. Next, let's look at the horizontal asymptote. Horizontal asymptote is if we had some sort of like horizontal gap there, where we'd be doing something like this or like this, you know, just something where it's going to approach a horizontal point. For horizontal asymptotes, you want to look at the original function. Now the powers are the same. So this is x to the first, x to the first. So since those powers are the same, you take the ratio of the coefficients. So if this is like 4 over 5, the horizontal asymptote would be y equals 4 over 5. It would just be that ratio. But since in this problem it's just 1x over 1x, the horizontal asymptote would just be 1 over 1, which is 1. So the horizontal asymptote is 1. So we have horizontal asymptote at 1. If the power in the denominator is greater, so this is like x squared, like the function 1 over x, for example, the power here is x to the first in the denominator, and then this is like technically x to the 0. So the power in the denominator is greater. That would be a horizontal asymptote of y is equal to 0. And then if the numerator is greater, then you'd have a slant. You have a slant asymptote. Okay. Now next. Horizontal asymptote. Let's get the intercepts. So let's gather x-intercepts. So x-intercepts. The x-intercepts are when the y value is 0. So where we cross the x-axis. So when the y value is 0. So I'm going to take that function, replace y with 0. So 0 equals x minus 2. Let me erase it. Over x minus 1. That's just going to be 0 times x minus 1 is 0 equals x minus 2. And add 2. X equal to 2. So we have an x-intercept at x equal to 2. Let's get the y-intercept. The y-intercept is where we cross the y-axis. So along the y-axis, that means our x value is 0 when we cross the y-axis. So we want to set x equal to 0 in this function. So we're going to have y equals 0 minus 2 over 0 minus 1. 0 minus 2 is negative 2. 0 minus 1 is negative 1. Negative over negative is a positive. 2 over 1 is 2. So y is equal to 2. So our x-intercept was 2, 0, and our y-intercept was 0, 2. So 2, 0, and 0, 2. And we had a horizontal asymptote at y equal to 1, so let's go ahead and indicate that also. So I like putting dotted lines for my asymptotes. If you're familiar with graph behavior and understanding what this graph is going to look like if you know what 1 over x looks like I was saying before, this graph of 1 over x, you can kind of get the idea of where these intercepts are, what this graph is going to look like. But if you want to be more specific, when you get to calculus, you'll be doing a lot more specific graphing where you're going to gather a lot more information. But like I said, this person did not submit how they wanted me to solve this. So I'm just going to use pre-calc type of method here. But from here, we have the intercepts, we have the domain, so we know where it exists, negative infinity to 1, 1 to infinity. We have the vertical asymptote, we have the horizontal asymptote, we have the x and y intercept. Next would be just grabbing some points. So I would say, what happens at x equals negative 2? What happens here at x equals negative 2? Where would I be? I'm just going to do it right here so I don't have to keep scrolling back and forth. So what do I get when x equals negative 2? I'd have negative 2 minus 2 over negative 2 minus 1. Negative 2 minus 2 is negative 4 over negative 3. So you get negative 4 thirds, positive 4 thirds, or negative 4 over negative 3 is positive 4 thirds. So you get the idea that negative 2, 4 thirds would put us right above that asymptote, because the asymptote is at 1. So at negative 2, we're right about here. And then you'd start to get the idea of, okay, this is just going to hug that asymptote down, and then this is going to hug this way. And you can grab more. You can do x equals negative 6, but it's just going to approach that asymptote, get closer and closer and closer. And then let's grab one for on this side over here of the asymptotes here. So in this corner here, let's grab x equals 4. Let's just do 4, I guess. X equals positive 4. So x equals 4. That's going to be 4 minus 2 over 4 minus 1. 4 minus 2 is 2. And 4 minus 1 is 3, 2/3. So at x equals 4, we have a y value of 2/3. So that's going to put us right below that asymptote. And you can grab more and more, but you get the idea that this is going to start just to hug this way and hug that way. And so there would be our graph. Now, if you were doing this with calculus methods, you'd have to find relative extrema, find the first derivative, second derivative, which this one would be quite a project to do because you'd have to use quotient rule. So if there is any need for me to do this problem using calculus, I will, but please let me know in the comments if you want me to do this problem again next edition for using calculus. I will, no problem at all. But that's what that graph would look like. So if you have any questions you want to send in, join the Discord, send an email, fill out the form, leave a comment. More than happy to help you out.